Okay, a sequence has the following three consecutive terms, so one after the other. So the first term is 7 a bracket x plus 1 minus 2. That's the first term. Term 2 is 3 a bracket x plus 2 times 3 plus 2x. So that's the second term. And the third term is 7 a bracket x plus 3 minus 2. Prove that that sequence is arithmetic. An arithmetic sequence, there will be a common difference between the terms. So you could say term 2 take away term 1 should give you the same answer as term 3 take away term 2. So that's what we need to do. Okay, so just keep them separate. That's term 1, that is term 2, and that was term 3. Okay, so if I go off to get the common difference, term 2 take away term 1 will equal the common difference. That was term 2. Take away, this was term 1, all right? So I would actually keep it all in a bracket, because then a minus multiplied by a plus 7 will be a minus 7 times the bracket, and a minus by a minus 2 is why that has suddenly become a plus 2. Okay, because it would have looked like that instead. So I just multiplied the minus, so term 2, take away, this is term 1. Then you're just grouping your like terms. Group all the x's together, they end up cancelling each other out. 3x plus 4x is 7x, 7x take 7x, gone. Then group your constants. 6 and 6 is 12. 12 take away 7 is 5, and 5 plus 2 is 7. So the difference between term 1 and term 2 is 7. If I can show that the difference between term 2 and term 3 is also 7, well, then I'm proving that it's arithmetic. So I am now going to do term 3 take away term 2. Term 3 was the purple one. Okay, 7 by x plus 3 minus 2. Take away term 2. Now I would have put all of that in a bracket and then multiply by the minus into the bracket afterwards. Okay, like this. So that was term 3. Take away, this is term 2. Multiply the minus into the bracket, and that's how it's now becoming minus 3 times that bracket. And a minus by a plus 2 becomes a minus 2 times that bracket. Then you just have to multiply out all the brackets and you'll get the next line. And then group your x terms together. 7x take away 3x is 4x, and 4x take 4x is gone. 21 minus 2 is 19. 19 minus 6 is 13, and 13 minus 6 is 7. So I got the same common difference, which tells me the sequence must be arithmetic, okay, because of the fact that you're getting a common difference. Question 18, the sequence has the following three consecutive terms. Prove that the sequence is not arithmetic. So this time, if they're asking me to prove that it's not arithmetic, well then I need to go and get a difference between the three terms, and that difference shouldn't be the same. That will then prove it's not arithmetic. So just make sure you know which term is which. That's term 1. That's term 2, and that is term 3. So term 2 take away term 1, I'll get a difference. Then term 3 take away term 2, I'll get another difference, and those two differences should not be the same. That will then state that it is not arithmetic. Okay, and also they make a note, x cannot equal 0. So basically if you get 0 as x, as your value for x, well that's also a way of disproving that it's arithmetic as well. Okay, so term 2 take away term 1. Term 2 was this, 3 a bracket x plus 2 minus 23. Take away, term 1 was 5 a bracket x minus 4 plus 3. You can multiply the minus into that bracket, so it'll end up being minus 5 times that bracket, and a minus by a plus is a minus 3. Okay, multiply out the brackets, tidy it up. You'll have 3x minus 5x would give you minus 2x. Okay, and then you have 6 minus 23 plus 20 minus 3. On the far side, this is term 3, take away term 2. So term 3, 5x minus 17, take away all of term 2, which I keep in a bracket. A minus multiplied by a plus 3 is going to give you a minus 3. And a minus by a minus 23 will end up giving you a plus 23. You then have to multiply out the brackets. Okay, group your like terms, tidy it up. And you will eventually tidy that up to b. So the left-hand side, I end up getting minus 2x plus 0, which is just minus 2x. So the common difference between term 1 and term 2 is minus 2x. But over here, the difference between term 3 and term 2 ends up working out to be 2x. Well, they're not equal to each other. This was minus 2x, this was plus 2x. I'm not getting a common difference, all right? And also, if you were going to solve, you'd end up getting out x is equal to 0, which they said it couldn't be the case, all right? Because if x was 0 and you subbed it back in here, term 1 would end up working out to be minus 17. Term 2, sub in 0, it would end up working out to be plus 17. Term 3, sub in 0, it would end up working out to be minus 17. To go from a minus 17 up to a 17, you've gone up 34 units. To go from a 17 down to a minus 17, you've gone down 34 units. So you haven't gone up by the same amount each time. It's going up and then it's going down. Okay, so therefore it is not arithmetic. Question 19. How many terms in this arithmetic sequence are positive? Okay, so I need to come up with the T of n formula for an arithmetic sequence. And then in order for it to be positive, it has to be greater than 0. A is 91. Common difference, it's going down by 2 each time. So common difference is minus 2. Okay, so I use my T of n formula, I sub into it, I tidy it up, and my T of n formula is now 93 minus 2n. I wanted to know how many terms are positive. So I'm going to let my T of n formula be greater than 0. And we solve for n. So I can bring the minus 2n over onto the other side, and it's now plus 2n is less than 93, or you can say 93 is greater than 2n. Divide across by 2, and you'll get n is less than 46.5. Remember, n has to be a positive whole number because it represents a term in the sequence. So it could be term 5, it could be term 30, right? So it has to be a positive whole number. So if n is less than 46.5, well then the largest term n could possibly be would have to be 46. Okay? So the 46th term, the first 46 terms in that sequence are all positive. Okay? The 47th term would end up being negative. You could check if that's correct. If I go and I get the 46th term, so I sub 46 into that T of n formula. Okay, so it was 93 minus 2n. That'll give me back 1. So the 46th term in that arithmetic sequence is 1. If I go and get what the 47th term would be, so the next term up from that, it's now minus 1. So you've gone from having a positive term to a negative term. So I was correct then to say that the first 46 terms in that arithmetic sequence are positive, and the ones after that then would become negative. Question 20, how many terms in that arithmetic sequence are less than 100? So again, you need to come up with the T of n formula for an arithmetic sequence and let it be less than 100. Okay, so the T of n formula, sub in A is 17, D was 4. Tidy it up, T of n equaled 4n plus 13. I want that to be less than 100. Okay, so let it be less than 100, solve for n, and you'll eventually get out that n is less than 21.75. N has to be a positive whole number because it represents a term number in the sequence. So if I'm less than 21.75, I round it down to 21. So the 21 terms, the first 21 terms in that sequence would all be less than 100. I can check if that's correct. Go and get term 21, sub it into your T of n formula here, then go and get term 22 and see if term 22 is greater than 100. So this is me getting term 21, works out to be 97. 97 is less than 100. I'm now going to go and get term 22. And it becomes greater than 100. So I now know my answer was correct to say that n equals 21. The first 21 terms would all be less than 100. Question 21, how many terms in that sequence are positive? Again, it's arithmetic. Come up with the T of n formula. A is 100, n is minus 3. Okay, so my T of n formula ends up being 103 minus 3n. I want it to be positive, so I let it be greater than 0. And we solve for n. Bring minus 3n over, and it'll become positive 3n. So 103 is greater than 3n, or you could read it as 3n is less than 103. Divide across by 3 to get n on its own. So 103 divided by 3 will give you 34.33 recurring decimal. So that's 34 and a third. So n has to be less than 34 and a third. N has to be a whole number. So the greatest number n could be, if it's less than 34 and a third, it'll be 34. So that means the first 34 terms in that sequence are positive, and you can check. Get term 34, and it should work out to be a positive term. Then get term 35, sub it into your T of n formula, and you should get a negative term. And that will then prove that the first 34 terms are positive, but the terms after the 34th term would end up being negative. Question 23. Show that the sequence T of n, which is in log format, log AR to the power of n minus 1, where A and R are real numbers, A has to be a positive number and R is also a positive number, show that that is arithmetic. Again, to show that something is arithmetic, I just need to show that one term, take away its previous term, will give me a constant. Okay, or that the difference between any two terms would be a constant. It would be the common difference. Okay, so I put down my T of n formula. Then I go and I get T of n minus 1. So where you have an n, replace it with an n minus 1. Tidy that up. N minus 1 becomes n minus 2. So that's your T of n minus 1 formula. That is one term, and that would be the term that is previous to it. So T of n, take away T of n minus 1, should give me a constant if and only if it's an arithmetic sequence. Okay, so one term, take away its previous term, and it's the general method. So this was term n, and this was term n minus 1. So now we just have to apply rules of logs. They both have a base of 10, okay, the invisible base of 10. Subtraction turns into division. So I can now write that as the log of AR to the power of n minus 1 divided by AR to the power of n minus 2. All right, they're all being multiplied together. I'm going to tidy this up. The A's would divide into each other, okay, they'd cancel each other out. I'm going to also look at my rules of indices here. So division turns into subtraction. Okay, so the A's cancelled. I was left with this. Again, the base numbers are both ORs. So then I can use the rules for the indices. Subtract the indices and see what you're left with. So it'll be the log of OR to the power of n minus 1. Take away the power that was underneath, which is n minus 2. Multiply the minus into that bracket. So now it'll be the log of OR to the power of n minus 1 minus n plus 2. The n minus n cancel each other out. Minus 1 plus 2 will give you 1. So I'll end up just getting log OR. All right, so don't mind this part here. So I went from there to here, down to here, and back here. So I get log OR. Now remember, at the start of the question, they told me that OR was an element of the real numbers and OR was a positive real number. Well, then that just means that that's a constant. Like OR could be 40, OR could be 29, OR could be 68. So the log of OR with a base of 10, invisible base 10, will just give me back a constant. So that is proving then that the sequence must have been arithmetic. 24. As part of a new tree planting initiative, Sean has to plant 30 trees on his farm in 2016, then 35 in 2017, 40 in 2018, and so on. So he's planting 5 more every single year up until year 2035. How many trees will Sean plant in the year 2029? So his starting point is 2016. Okay, and he's going to plant 30 trees in that year. So I just need to go up as far as 2029. Okay, so term 1 is 2016. By the time you get to 2029, you're at term 14. So I'm literally just looking for term 14. A is your first term, 30. The common difference is 5 every single time. So you can sub that into the T of n formula. So it'll be A plus n minus 1 times D. So that's 30 plus n minus 1. Well, n is 14. So 14 minus 1 is where I'm getting 13 from. Multiplied by the common difference of D, and you get 95 trees. So he'll plant 95 trees in the year 2029. Okay, part 2 then said, in what year will Sean plant 75 trees? So you let your T of n formula equal 75 and you solve for n. That will tell you which term in the sequence would he have planted 75 trees, and then you can work back to see what year that would have been. Okay, so my T of n formula, which tidied up to be 5n minus 5, let that equal your 75. Okay, or sorry, it actually tidied up to be 5n minus 20 plus 25 is what it was. Okay, we brought the 25 over, subtracted it, tidied it up. We'll eventually get out that n is equal to 10. N represented a term number. So in term 10, you have to figure out what year is term 10. Remember, you started in 2016, that was term 1. Term 2 was 2017. Term 3 was 2018. So by the time you get to term 10, it's the year 2025. So in 2025, he will plant 75 trees in 2025. Okay, so I now want to draw a graph to show the number of trees that would be planted in each of those years. Okay, so it's a linear function, so I'm going to be graphing a straight line. Draw an XY axis and label it. Okay, so they want us to just do the graph from the year 2030 to the year 2035. Grand. So X-axis is the year. The Y-axis is the number of trees that he's planting. Given that in 2029 he planted 95 trees, well then obviously the following year he would have planted 100 trees. So in 2030, he would have planted 100 trees. So that's my starting point. So the year 2030, he planted 100 trees. So I would plot a point. In 2031, he would have planted 105 trees. So they're going up in 5. So 2031, go to 105, plot your point. 2032, he would have planted 110, plot your point. 2023, he would have planted 115. 2034, he would have planted 120. And 2035, he would have planted 125. Get your ruler, connect those points. Okay, so you have now graphed that linear function over the years from 2030 to 2035. Question 26. An architect is designing a skyscraper. He has been told that each floor must contain exactly 90 rooms. He has constructed a table showing the total number of rooms on each floor and all the floors that are below it. Part of the table is given below. Okay, so on the first floor, these are the number of rooms on that floor and all the floors below. So first floor, there's 90 rooms. Second floor, there's 180 altogether accounted for. That means there's 90 on the first floor, there's another 90 on the second floor, which means altogether there's 180 rooms already by the time you get to the second floor. By the time you move on to the third floor, there are now 270 rooms in the skyscraper from floors 3, 2 and 1. If you've already accounted for 180 of them in floor 2, well then 270 take away 180 is 90. There's another 90 rooms in floor 3. Floor 4. There's 360 altogether, so that's 360 combined from floor 1, 2 and 3. All right, so again, 360 take 270 means there was another 90 rooms in floor 4. And lastly, 450 take away 360 will give you another 90 rooms that must be on floor 5. Okay, construct the next 5 rows of the table. So you're just going to be adding on 90. Okay, so 540, 630, 720, 810 and 900. So by the time you get to the 10th floor of the skyscraper, there are 900 rooms in the building up as far as the 10th floor. All rooms on the first 20 floors will be equipped with a special security door. How many of these security doors will be required? Well, if every room has a security door, I just need to know how many rooms are there by the time you get to the 20th floor. Okay, so I need to get term 20. A is your first term, 90. The common difference each time, it was going up by 90 each time. So get your T of n formula. So your T of n formula, when you sub in A is 90 and D is 90, that works out to be 90n. So T of n equals 90n. I now want to get T20. So how many rooms are there in the first 20 floors? So sub in 20 for n, and you get 1800 rooms. If there's 1800 rooms in the first 20 floors and every single room has a security door, well then there must be 1800 security doors. The building must contain 9090 rooms altogether. How many floors would the skyscraper have? Right, you've already come up with the T of n formula from the previous part. The T of n formula represented the number of rooms that were in the entire skyscraper. So let the number of rooms equal 9090 and solve for n. N will tell you what floor and all the ones below it had 9090 rooms altogether. So you'll know then how many floors the skyscraper had. So that was my T of n formula, so I'm going to use that. Let it equal 9090, divide across by 90 and you get 101. So there must have been 101 floors in the building to say that there was 9090 rooms.